All right, good afternoon, everybody. Let's see. So, question from someone in chat: how do I look at mail when I log into the Linux server? So, first of all, in general, we probably don't want to be using mail on the Linux server a whole lot. There's a few times when I find it really useful to have you send me mail there. For example, when I'm trying to collect information on your Git IDs. If you send me email in Canvas or in Outlook, I have to, go through each message and copy and paste and all this kind of stuff. If you send it to me on the server, I can just, run one or two commands, grab all of the subject lines, run them through some processing tools, and make my file of Git IDs. So in general, we're not going to do mail on here, but if you want to send mail to me, mail Nick, enter, subject, this is a test, and then just type in your message. You don't get any prompts or anything. You can end with either a Control D or a single line with just a period, and you'll get EOT, end of transmission. All right, thank you. All right, so my microphone was off. All right. In general, I don't plan on using email a whole lot on the Linux server, but once in a while it's useful to be able to get information from the class in kind of a standardized form. And if you send me, say, your Git ID with a standardized subject line on the Linux server, it's really easy for me to grab all of those subject lines, put them into a file, make my GitLab ID database so I can download your submissions, for example, as opposed to going into Canvas or Outlook and having to, point and click 100 times. But in general, we're not going to use Linux mail, okay? Nonetheless, if you want to send mail to me, right, the command is just mail and the Linux user ID of the person you're sending mail to. So mail Nick, subject, whatever your subject is, and then you just start typing in your message. Okay, this is a test again, goodbye. And when you're done, either hit Control D or enter a line with just a period in the beginning, and you get EOT, end of transmission, and that's it, your message is sent. Now on the receiving side, right, either when you first log in or after you hit enter, you'll get a message saying that you've got mail. So let me go ahead and log in again. I get my welcome message and it tells me you have new mail. Alright, so if you want to know who the mail is from, there's a command from. It will show you just the subject lines, the header lines, one per message. So I know I have two email messages now. They're both from Nick. I can see when they were sent. Okay, if I want to read my mail, I can just use the command mail, and I'll see my first 20 or so messages out here. If I want to read message 1, I can just hit enter and there's message 1. If I want to read the next message, I can hit enter and there's message 2. If I hit enter, it'll tell me I'm at the end of my file. If I want to read message 1 again, I can say 1. If I want to see my headers again, I can say H. If I want to reply, I can say reply and it'll tell me I'm replying to this person. I got your message. Hit a period to end and you're set. Alright, when you're done, you can just say exit or quit, or Control D is the usual way. If you do Control D, it saves your mail in a separate file. And I also got a message now saying that you have mail, so I can go back in with the mail command, and there's my one message. And if I say exit, it won't get rid of that message, it'll save it for me, so when I go into mail, it's still there. If I exit with a Control D, it saves it for me in this file called mbox. Then I could say mail-f and the name of that mailbox, and it will pull that in. So I'm not going to go into a whole lot of other detail in class, because like I say, we're really not planning on using this as a regular thing in this course. But if you want to get emails from one another, you can do that. In a few cases, I replied to people who sent me emails other than, with their Git ID. I replied to them using the Linux emailer because I assume you know how to use that. But in general, don't worry about it, right? Stick to mailing me at, nmaciasclark.edu. Don't use Canvas to email me, okay? I'm going to stop responding to those pretty soon because Canvas is not reliable for email, for me at least. So if you want to reach me, do regular email to my Clark email address. All right, other questions? So I want to take a look at the current ODP, which posted at 8 o'clock this morning. So again, your ODPs open at 8 in the morning, or 8:05, and they close at 8 the next morning. So the current ODP is 406. That will close at 8 tomorrow, and then at 8:05 tomorrow, ODP 407 will open up. All right, so let's take a look at ODP 406. So README 406 tells you everything you need to know, right? ODP 406, you're writing a bash script, not a C program, a bash script that reads a number as a program input. Okay, this means that you're going to run the script, ODP 406, hit enter to run the script itself, and then it's going to wait for you to type in a number. And you'll type in that number you can assume is an integer. You want to print out that many pipes side by side, followed by the number in parentheses. So for example, ODP 406, that's running the script. I type in the number 5. The program should print out 5 pipes, followed by parentheses, 5 close paren, new line, end of output. All right, so I'll show you a live example of this. ODP 406 is my solution for the ODP, or not. All right, here's my ODP 406. So I hit enter. It does not print anything. There is no prompt. There's no welcome to my ODP. There's no how many sticks would you like to see. No prompt at all. That's important. Okay. If you print out a prompt here, if you print out a single space, 0 out of 10. All right. I'm not grading this. This is graded by my automatic grading system. It doesn't understand that when you print out a % sign, that's harmless. Okay. So no prompt. Just sit here, wait for the person to type in a number. They type in a number and hit an enter. You print out that many pipes side by side with the number in parentheses, new line, and you exit. All right. That's got to be exactly the behavior of your script. Anything different, and it's going to give you 0 out of 10. All right. So how do you do this? Well, you read the number by just saying read n, right? And that'll wait for the person to type something in. Whatever they type will be in the variable n. And then you make a while loop. So have a counter, initialize it to 0, do while that counter is less than $n. So use your -LT switch. And then inside your loop, you want to print out a pipe. Okay? But if you just say echo pipe 45 times, they're going to come out on 45 lines. So you want to use a switch. Your switch is echo -n. The -n switch says don't move to a new line after the output. Okay, so this is a useful and critical version of echo -n. So if I say let's do this in a script. Alright, so here's a sample script. It prints out 5 pipes side by side, followed by the number 5 in parentheses. But I did those pipes one at a time on separate lines, right? That's what the -n switch lets you do. It says go ahead and output this, but don't go to a new line yet. So these things, this should be happening inside your while loop. If n is 45, go through your loop 45 times, and each time through, output one more pipe. And then at the end of your loop, output a parentheses followed by the value of n, right, followed by close paren, and then exit. All right, so that's all that's all that your ODP has to do. For homework, it isn't automatically graded, right? Homework 3, yeah, so the homeworks are graded by me. So for homework 3, for example, I don't care what your greeting looks like. I want some kind of greeting. But if your greeting is one line, you know, let's play a game. If your greeting is a paragraph, that's all fine. So your homeworks, like homework 3, are strictly graded by me. However, I do automate the running of your script, and in some cases the feeding of input to your script. So for example, if I say that you should accept a U lowercase for user, a C lowercase for C, and anything else should you know, print a message and try again, your code has got to do that, okay? Because I'm going to run a script which will run your script and give it, you know, an X, or give it an uppercase C, or give it an empty line, and I'm expecting it to do certain things. And if the only way I can get your game to run is by putting in an uppercase C or an uppercase U, then I have to run it by hand. And guaranteed it's going to get extra special attention in that case, okay? Which means it's going to get extra tests and so on and so forth. So make sure you follow what is specified in the prompt, okay? But if it's not specified in the prompt, you can do anything that you like, basically, and it'll work, because I'll be the one grading it and looking at it. All right, so write your ODP 406, test it out, make sure it works, okay? Don't just assess it, make sure it works for you at the command line. Run it, put in a number, make sure it prints out that many pipes followed by your number in parentheses. Do some small numbers of pipes to make sure that it's actually doing it and you're not counting wrong. There I've clearly got one pipe followed by the number 1. Here I've clearly got 2 pipes followed by the number 2. Okay, now I'm pretty confident that ODP 406 is correct. Alright, so I'm going to go ahead and assess it. And before you do anything else, take a look at the stuff inside the lines of asterisks. It says you are about to assess your code for ODP 406. Input a positive number with a typo, print that many pipes followed by the number in parentheses followed by a new line. All right. If you're writing ODP 407 because you looked at the README this afternoon and you try to assess ODP 407 and you see this message which says you're about to assess for ODP 406, stop what you are doing. Exit out. Just use an X command. Because if you assess ODP 407 but it's looking for 406, you're going to get a 0. You're going to get a 0 on ODP 406. And if you don't go back and resubmit ODP 406 to get 30 out of 30, you're going to end up with a 0. Okay, so I sent an announcement. About 20% of the class did this on the previous ODPs. They assessed for the wrong assignment. That's what this is for in the output of the assess command between the 2 lines of asterisks. It tells you what you're about to assess for. Make sure that's what you're intending to do. All right, chat question. Could we add additional functionality to the homework, for example, make it so you can change how many sticks you can take? You can add extra functionality, but do not break the core functionality. Okay? So for example, don't have an extra input at the beginning saying, would you like to play by the standard rules, yes or no? And if the person says no, okay, we're going to play by extended rules. Don't do that, okay? because that's not in the assignment. The assignment is ask how many sticks, ask who goes first, and then start playing the game. But if you want to put a switch option on the commands, you can say stick space -X, and that'll bring in extra features and so on. That's totally cool. Okay, and then in your README, you can tell me about extra things that your program will do, and I can look at that and so on. Or in your comments, right up in the top, you can say, you know, extra features available, and I'll look at that. But if you add extra stuff, make sure it doesn't change the core behavior. Okay, so no extra prompts, no extra requirements, and so on. All right, so it says ODP 406. Use the G command. You should get 10 out of 10 on every test. That gives you 30 out of 30. You're good to go. Go ahead and exit. All right, so 406 is open now. If you look at Canvas, you'll see which ODPs are open. That's 406 right now. The README for 407 is posted in /temp, right? That's just a file. But 407 doesn't open until 8:05 tomorrow. Check Canvas to see which one is currently open, or try assessing and read this message. Once this says you're about to assess for ODP 407, then you're good to go ahead and assess 407. All right, does that make sense? All right, let's go back to looking at pseudocode. So I want to look at pseudocode for 403. We started looking at some of this last week. I want to go into more detail and basically spec out pseudocode that'll work for the entire homework 3. So homework 3 is due Friday, remember. So let's look at homework 3. Now pseudocode, this is going to look a little bit like C, a little bit like bash, a little bit like nothing. I'm not writing bash code here. Okay, even if it looks like bash, this may not be the correct syntax for bash. This is high level. This is for us. Okay, this is what we're looking at and thinking about and changing and running through in our heads before we actually write the code. Okay, so what does homework 3 do? It's going to print out some kind of greeting. Welcome to my game. You know, would you like instructions? No, don't ask that. But here's the instructions for playing stick, and so on and so forth. So print out your greeting. Get the number of sticks that you want to play with. So how many sticks would you want to play with? Must be bigger than or equal to 10. Get a number, make sure it's legal, loop if it's not, and so on and so forth. Get who goes first. And let's suppose that when you get who goes script, you save that in a variable called turn. And U means the user goes first, and C means the CPU goes first. All right, now we need to loop. We need to alternate between a user move and a CPU move. But it's a little tricky to get this started. Because if I make my loop, you know, have the user take a turn, have the CPU take a turn, user, CPU, but the person said, I want the CPU to go first, we don't want the user to take a turn first. We want the CPU to take a turn first. On the other hand, if the player says the user should go first, then we should have a user turn followed by a CPU and a user CPU. And if we write our loop to say CPU user, we need to skip that first call to CPU, right? So we need to be a little careful how we wind this up to get it going. Let me show you a really easy way. We're asking the user who goes first. We're assuming we have a variable called turn, which is either U or C. Okay. So here's some logic that will take care of this. If turn is user, then let's just do the user turn. And now I'm going to make a loop CPU turn, user turn, infinite loop. All right, and this is the little hook here that's going to let us handle who goes first. Because if the user wants to go first, this statement will execute and take a user turn. And then we go into a loop, CPU user, CPU user. If the player decided the CPU should go first, we will skip this first call to user turn and we'll start the game by saying CPU turn, CPU user, and so on. So that's a pretty easy way to manage this business of someone might go first or someone else might go first. Just throw an extra statement here in the beginning. But this user turn and the CPU turn, I'm assuming those are functions or additional scripts or something like that. If I'm writing everything in one big long monolithic script without the use of functions or anything, then all the code that goes into the user turn has to get replicated up here, and that's undesirable, right? We never want to take a whole bunch of code and just copy and paste it in multiple locations. Because one, it's extra wordy, it's harder to read, but two, if we have to change that code, we have to change it in all these different spots. Right? So anything that's going to be more than a few lines of code, we're going to throw into a function or a script. All right, so I'm assuming I have, in this case, a function called user turn. We call it there, we call it here, we call CPU turn here. There's a different way we could do this. We could simply code our loop as follows. If the turn is user, then take the user turn and change the turn to CPU. Else, take the CPU turn and change the turn to user. And we could put all that in an infinite loop. So we're assuming before we start this, we've gotten the turn from the player and they've selected either the user or the CPU. And now we have an infinite loop which will do one of two things each pass. If the turn is set to user, it'll take a user turn, and it will change this flag so that the next time through it takes a CPU turn. Otherwise, if the turn is not user, it can assume it's a CPU turn. It'll take a CPU turn, set the flag to be user. So like this, each time through our loop we get a pair of turns. With this structure, each time through our loop we take one turn, but we alternate user versus CPU versus user. Alright, no way is better or worse than the other, right? This works perfectly fine. This is using the notion of a state variable, right? We're using this variable turn to store and update the state of the system. And the state says, whose turn is it? And the behavior of the body of our loop is dependent on the state of the system. If we're in a state where it's the user's turn, then this loop will do the code for making the user's turn. If the state of the system is that it's the CPU's turn, then this same block of code will have the effect of running the code for the CPU's turn. Okay, two fundamentally different looking approaches, same effect in the end. Do whatever makes sense to you. If there's a different way to do this that makes sense to you, do that. Okay, I want your code to make sense to you. I want it to make sense to me too, but I want it to feel natural to you. All right, there's also the question of how we exit this thing. This is an infinite loop. This is an infinite loop. How do we exit? There's a few ways to do that. I'll tell you the absolute easiest way. If these are functions, user turn and CPU turn, just have them execute the exit statement when they decide that the game is over. They can print out the final outcome, right? Tell you who won. They can thank you for playing. They can say exit. the whole script will exit. That's your easiest approach. The other approach is to have these things set a flag saying, you know, the game is over, and then instead of making this an infinite loop, make it a loop while the game is not over, right? Or while gameplay continues, and have these functions change the value of that loop variable when the game is over. Okay, that's a little cleaner because in your main program you can see the conditions under which you exit. Whereas if you write your main program like this, it's not clear that this loop ever finishes. It just looks like an infinite loop. But in fact, you know, you have to know that these things will exit at some point. You can do either of those that you like, or you can do something different. Okay, I'm okay with global variables in scripts for now. I'm not going to be okay with global variables in C code, but for bash scripts that's fine, because passing values to and back from functions can be a little tricky in bash. So if you want to just have a global variable called, you know, game is over, and have these things set the value of that to, you know, something to indicate the game is over, put that in a while loop, that's totally fine. Okay, so globals are okay in bash scripts like that. All right, so let's keep going with this one. So how do we do the greeting? Well, that's just a bunch of echo statements. But if you put it in a function called greeting, my main program, first line is just greeting, right? And I don't have to see 15 echo statements when I'm looking at my main program. I see the word greeting, it's a function call, there's a comment over here which says, you know, welcome the user, tell them the rules of the game. And then somewhere further down in my script, there's the actual code for greeting with the 15 echo statements in it. So my main program, all of that's handled by one function call. Get the number of sticks. Well, we did pseudocode for that last week in section A of this class. You can find the video on that. But that's basically, you know, a loop which asks the user how many sticks, checks to see if it's a legal number. If not, asks them again, keeps doing that until it gets the legal number, and then it's done. Right? So you could have this be a separate function, get number of sticks from user, get number of sticks we want to play with, I don't know what you want to call it, and have that, you know, store the final number of sticks that are selected in a variable like number of sticks. And then see who goes first. Well, we went through pseudocode in this class for that last week, and you can have a variable called turn. And same thing, ask who goes first, U or C, get the user's answer. If it's not a U or a C, remind them what they should answer, try again, keep doing that loop until they put in a U or a C, and when you're done, this variable turn is equal to either U or C, right? So first 3 lines of my main program can be just 3 function calls. And now if I'm looking at my main program, it's really easy to see what's happening step by step. I'm greeting the user, I'm finding out how many sticks we're playing with, I'm finding out who's going first. Alright, this is an if statement with a call to user turn. If bracket bracket quote $ turn close quote space equals equals space quote u quote space bracket bracket new line then new line user turn new line fee. Alright, and that's pretty easy to read in the main program, especially if you have comments, so that after you call get number of sticks, put a comment saying, you know, number of sticks is stored in numsticks. Turn of first player is stored in variable turn. U equals user, C equals CPU. Put it in your comments, and someone looking at your main program, they know exactly what's going on in the system once they get to this point of your code. And now they see this if statement which says if turn equals U, they know, oh, that's the turn that was just specified by the user in the previous function call. And if it's a U, they said the user should go first, and we're calling a function user turn. Put a comment on that call, right? Get number of sticks, subtract from pile, see if game is over. When you're done with all of this, you should be able to look at the main program part of your script, which will be, you know, less than 10 lines of code if you do it like this, and really easily understand how the program flows. It does this, 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 it conditionally does that, and then it does these 2 things in a loop forever, until one of those 2 things exits from the script. And I guarantee you, when you're trying to finish up this program, and you're trying to get the last details worked out, and you're doing the edgy test cases and so on, if your main program looks like this, life is going to be a lot easier than if your main program is 117 lines of bash code with nested if statements inside loops inside other if statements, where your first if statement is 56 lines long, right? Modularize, break out functions into logical pieces, put those into separate bash functions or separate scripts, and just call them. Okay, it's going to help a lot. Alright, so we've got pseudocode for those first three pieces. This is just an if statement. The only thing we need to spec out now is these two functions, CPU turn and user turn. Alright, so let's look at those. So I'm going to assume I've got some variables running around here, right? I'm going to assume that I have number of sticks equals number of sticks left. So what do we want to do in here? We want to figure out how many sticks we should take. Well, we had a formula for that, right? The formula was take the number of sticks left in the pile modulo 5. So there's a modulo operator in bash. It's percent, just like in C or Java. So, you know, take equals $paren num sticks %5, 2 close parens, right? This is pseudocode. Let's take the number of sticks modulo 5. That's how many sticks we would like to take to be able to win the game. The detail is, if the number of sticks left is a multiple of 5, we'd like to take 0 sticks so that the other player ends up with a multiple of 5, but taking 0 sticks is not a legal move. This might tell us to take 0 sticks, so we have to check for that condition. So if take equals 0, set take equal to 1. So set take equal to numsticks modulo 5, unless that gives you a 0, in which case set take equal to 1. Alright, so announce I take $take sticks. Right? So that's one requirement, is tell the player how many sticks you're taking. Subtract that from the pile. Right? Not bash code, pseudocode. So you got to do some work to change that into bash. So take that off the pile. And see if the game is over. If numsticks is less than or equal to 0, I win. Okay, what do we do for this I win business? You know, tell the user that you won, gloat a little, you know, call them a silly human or whatever, and then just exit. Alright, thank them for playing if you like, and so on. But this is going to be some echoes and then an exit. Alright, so if numsticks is less than or equal to 0, the game is over and the CPU has won. Okay, otherwise, show the pile of the sticks. Well, you could make a function called showPile, and you could pass it the number of sticks that are left. Or you could make showPile just read the number of sticks variable, right? And this is basically ODP 406 with a little bit of a modification. ODP 406 waits for the user to type in a number and then prints out that many sticks. What you want this function to do is either take an argument or just look at the numSticks variable and use that as the number of sticks to display, print out that many sticks, followed by a parentheses, followed by the number and a close paren and a new line. So you can repurpose ODP 406 for this function right here to show the pile of sticks. Right? And then return. That's the end of the CPU turn. So figure out how many sticks you'd like, adjust it if necessary, tell the player how many sticks you're taking, subtract it from the pile, see if you've won the game, and if not, show the pile of sticks. That's the whole CPU turn. So that's that piece right there. All right, the user turn is almost exactly the same. The only difference is, instead of calculating how many sticks the user should take, you have to ask the user. So, I don't know, I'll make a function called getUserNumberOfSticks, or whatever you want to call it, right? Something that asks the user how many sticks they want to take, and takes their answer and loads it into this variable named take. Okay. You don't have to tell the user how many sticks they're taking, because they already know. But then just go ahead and do all the rest of this. Subtract that number from the number of sticks. If the number of sticks is less than 0, tell the user that they won. Print out a message, congratulate them, exit. Otherwise, go ahead, show the pile of the remaining sticks, and return. So once you've written this code, user turn is almost exactly the same. The main difference, other than wording of things, is that instead of calculating the number of sticks to take, you're going to call a function to ask the user how many sticks they want to take. Alright, so that's our last piece. So get the user number of sticks to take. Call it something that sounds cooler than that. Alright, so what do we do? Prompt. Get the variable take, how many sticks they want to take. If that's a legal value, return, we're done. Comment. The person made an illegal choice. Warn the user that they made an illegal choice and they only have one chance left to make a correct entry. Get their answer. If that's legal, return. Forfeit misspelled. Yell at the user for cheating and exit. All right, so the key idea here is modularizing, right? We have lots of code, we have lots of code, we have additional code, we have more additional code, right? But the pieces themselves should be pretty small. And you know, this function, I can test the heck out of this by itself. I don't have to have a working stick game. I don't have to have instructions, I don't have to have anything except this function. I can just call this function and you know, It'll tell me how many sticks do you want to take, and I'll put in a number, and if it's legal, take should be set equal to that. If it's not, it should warn me, and so on and so forth, right? And I can thoroughly exercise that function, and once I'm convinced that this works exactly as I want it to, right, it just becomes a function call in my user turn. And how do I know if a move is legal? I could write another function for that. I can pass it a number. It'll tell me if that number's less than or equal to 4 and bigger than or equal to 1. Now, it's one if statement. It's probably not bad to put here, even though I'm doing it 2 spots. You know, it's a personal choice. Do I want to make a separate function for this and pass a value to it and pass a flag back from it, with the extra overhead of declaring a function and having some parameter passing mechanism, or do I want to write my if statement twice? Probably here I would just write my if statement twice, because to some degree, you know, being able to look at everything in one spot of my code is easier, right? Unless, you know, this line is 50 lines of bash, and to get from here to here, I've got to get through 50 lines of this self-contained function, right? Personal choice. Play around with it. Find something that works for you. It's not the same for each person. It's not the same from day to day for one person. It's not the same from assignment to assignment. But play around with it. Figure out what works. Okay? And use lots of commenting to help you understand what you're doing, how you've modularized this code. Okay? That'll help you also. All right, questions about any of that? All right, let's talk about C code. So we're going to change gears here. I want to talk about C from kind of a high level, starting with the whole GCC business, and then we're going to spend the next few days digging into some of the details of actually writing C code. In particular, doing input from the command line and from user input while the program is running. All right, so GCC. Here's our usual way to compile a program like hello.c. So GCC, that's the command we're executing. This is the GNU C compiler. This is what I'll call our source program. That's the human readable code that we're trying to compile into an executable program. Okay, if we just say gcc hello.c, we get a file called a.out. That's our executable program. But we're using a switch, and the -o switch says, I'm going to tell you what to call the executable program instead of a.out. I want you to call it hello. So this is the output file, which is the executable program. So all of this will read a .c file, which has human readable source code in it, compile it as a C program, and produce an executable program called hello. Alright, so there's our C program. There's our GCC statement. there's our executable program. I can type its name, it gets run, and it does what the C code said to do, which was to do a single printf, which prints out the word hello. All right. Hello.c is a 56-byte file, so that's pretty small. Hello, the executable, is 8,600 bytes, right? Quite a bit larger. And if we look at this hello file, it's got gibberish inside, stuff that we can't understand. It's got a lot of these @ signs. Well, this is how ASCII code 0 is represented in this display. So these are nulls. A lot of nulls in most binary files. There's a few printable characters, right? So here's the letter U, followed by A, followed by T, followed by L, followed by unprintable character %3/4 Control H, right? So mostly stuff that's not meaningful to us, but you know, there's some human readable stuff in here. So a fun command to know is strings. So strings will read from an input file, and any collection of characters that are printable, that are human readable, it will display to us. So if I say strings hello, it won't show me all the binary contents, but it will show me the stuff that's so-called human readable. So here's something from the library that it's loading. Here's the C library. There's a put statement somewhere. glibc, this is Ubuntu, so I'm running Ubuntu, so that's showing up there. Here's C runtime library stuff, whatever that is. And so there's miscellaneous things in here. Here's hello.c, that's the name of the file I compiled, so that's stored in the executable, which is kind of interesting. And there's other things in here. Here's main, that's the name of my main program. The symbol table where variables are stored and so on and so forth. So there's stuff in there, right? And somewhere in here, hey, there's the string hello. That's what my program prints out, right? So this is binary code, but the string command will let us see that. xxd is another command that will let us look at binary files without blowing up our screen, so we can see that the first character in the file is 7f. That's a delete code, followed by 45, 4c, 46, that's ELF. Well, printable stuff shows up over here, ELF. Non-printable stuff just shows up as a dot. This is a picture of the contents of your file. We have addresses over here, so starting with 0. So the first byte is right here. The next row of this output starts with hex 10, so that's character 16. So this is character 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then character 16 is right here. The third row starts with character 32, that's 20 hex, and so on and so forth. And so XXD is one way that you can look at the contents of your file without it blowing up, because if I just cat hello, I get all kinds of weird stuff, and sometimes it leaves your terminal in some weird state. Things are bold-faced or reversed videoed or things like that. So XXD is a useful tool. So what I want to do tomorrow is I want to look at these 5 statements in our C program. The curly brackets, there's not a lot to say, but I want to look at this include statement, see what exactly that's doing, what does it mean when we include, and that's going to be important down the road when we talk about make files. I want to look at this statement and then this print statement and just sort of take apart this most simple C program, the hello world, and then we'll start talking about programming in C. And we're going to look at command line arguments, we're going to look at ways of doing input while the program's running, and I also want to look at VI. Okay, so we'll probably do VI tomorrow also. I want to start getting into better ways to use VI than how a lot of people use it. So we'll try to get more proficient with that. All right, have a good afternoon. I will see you next time. Thank you.